In this video, we're going to be talking about some more rules of differentiating. We're going to focus in this video on the product rule. The product rule is what you have to use when you find derivatives of functions that are being multiplied together. When you find the derivative of functions that are being multiplied together, you use this form called the product rule. And it simply says, find the derivative of that first function, multiply it by the original second function, plus the original first function times the derivative of the second function. Let's do an example and see what that means. So anytime you notice that you have terms that have variables and they're being multiplied, it is true that you could distribute and instead use the power rule, but it is important that we understand the product rule as well. So we're going to, instead of multiplying these out and using the power rule, we're going to use the product rule. So I have 4x cubed times the other function, x cubed minus 6. We're going to find the derivative of that. Just separate each of the functions and find the derivatives of each separate function. And then we'll just plug it into that form that we saw above. So if we say that the first function is 4x cubed, then we can find the derivative of that. The derivative of 4x cubed using our power rule becomes 3 times 4, and subtract 1 from that 3 and we get 12x squared. Then take that second function and find the derivative of that. So the derivative of x cubed minus 6, drop that exponent down, subtract 1 from it, we get 3x squared. The derivative of a constant number is 0, so the final derivative of that function is 3x squared. Now that we have the derivative of the first function and the derivative of the second function and their original forms, we can just plug it into that product rule form. So here's that product rule form. We're just substituting the derivative of function f was 12x squared. The original g function was x cubed minus 6, plus the original first function, which was 4x cubed, times the derivative of the second function. And we found the derivative of the second function to be 3x squared. Then we can put it together, simplify, combine any like terms. 12x squared times x cubed is 12x to the fifth. And distribute the 12x squared to the negative 6, we get negative 72x squared. Plus the product of these two, 4x cubed times 3x squared is 12x to the fifth. We got two like terms, 12x to the fifth plus another 12x to the fifth gives us 24x to the fifth, and that minus 72x squared is left over. We always want to try and rewrite functions in descending order of their exponents. So always put the highest exponent term first, followed by ones that are lower than that. Let's take a look at an example that has multiple terms in each of the functions here. We're going to follow the same step. The first function is 3x minus 2x squared. The second function is 5 plus 4x. Since we notice that we have two functions being multiplied together, we're going to use that product rule. To find the derivative of the first function, the derivative of 3x minus 2x squared is just 3 minus 4x. The derivative of the second function, 5 plus 4x. The derivative of 5 is 0, so we're just left with the derivative of 4x, which is 4. Now we can put everything together into that product form. Derivative of the first function, 3 minus 4x, times the original second function, 5 plus 4x, plus the original first function, 3x minus 2x squared, times the derivative of the second function, which was 4. Distribute and simplify, combining like terms if you need to. Let's FOIL this out. 3 times 5 is 15. 3 times 4x is 12x. Negative 4x times 5 is negative 20x. Negative 4x times 4x is negative 16x squared. Just distribute that 4 through this last binomial here. 4 times 3x is 12x. And 4 times negative 2x squared is negative 8x squared. Combine any like terms that you find and rewrite it in order of their exponents. So x squared is the highest order, so we'll combine those like terms, negative 16x squared and negative 8x squared. Combine to give us negative 24x squared. Our x to the first powers, we got 12x plus 12x minus 20x. So 12x and 12x give us 24x, minus 20x gives us 4x. And then the last term, the leftover, plus 15. So here is our derivative representing the slope of our original function, that product function. This is the slope at any point. Now all we have to do is plug in an x value and we can find the slope of that function at that specific point. So there's the product rule.